So in part one, we finished with the idea of talking about simple random sampling. To give you guys an idea of what simple random sampling looks like, think of our class. We have 16 people that are enrolled in AP Statistics. If I wanted to ask 5 of you guys for your opinions on how the first semester went, a way I could randomly sample from our group is to ask or to give each person a number, let's say 0, 1 through 1, 6. I could assign those numbers alphabetically, or I could assign those randomly. And then using this random number generator, I'm going to start in a random spot, let's say here, and I'm going to go through and see who gets picked. And the first 5 people get picked. If that sounds familiar, that's because we've run through these types of simulations before. And that's the idea behind simple random sampling. The problem is we have only 16 people, and that's relatively easy to do in our classroom. But what if I wanted to do it with the entire senior class? Or if I wanted to do it with the entire school? In order to get a representative sample, I would need to increase the number of people I ask. And by finding the entire list and then numbering off each of those people, it starts to become a little more challenging. Not undoable, but just more time consuming. So there are other techniques of random sampling that we use to overcome problems of which statisticians are aware of. And these usually go with time. So the first different way that you could utilize with or exclusively from simple random sampling is stratified random sampling. So sometimes the population is first divided into homogeneous groups. We call those strata. I want you to think rock layer formations, and you separate the layers, which are called strata, which designate different timelines. That's what we mean by stratification. So divide the population by some important characteristic to attempt to balance the sample. Doing so ensures our sample contains the desired distribution of that characteristic. Strata could be grade level. So we have freshman, sophomore, junior, senior. They are roughly the same size. Those could be the strata in our school. Then we simply use simple random sampling within each stratum, that's the singular, and combine the results to create our sample. So you see how stratifying, let's say I want to get 80 people total, and I want 20 people from each grade. So if I look at the strata, it's smaller numbers to collect with each class to get the entire picture of what I want for a representative sample to ask our school. This common sampling design is called stratified random sampling. So for instance, suppose we wish to choose a sample from our population of interest, that is the students from DCHS. If we believe that the class of the students for 9th, 10th, 11th, and 12th grade might have an influence on the results, we'll want to ensure our sample has an appropriate number of seniors, juniors, sophomores, and freshmen. To ensure the appropriate representation, we will randomly select the correct number from each class, the class being the strata, to accurately reflect the ratios in the population. The end result is a sample with the same proportion of each class as we expect to find in the population. So if we know that the junior class is smaller than the incoming freshman class, we can adjust for those smaller number of people in the proportion that we use. So the most important benefit of stratifying is that stratifying can reduce the variability of our results. When we restrict by strata, other samples are more like one another. So statistics calculated will vary less from sample to another. Stratified random sampling can also reduce bias by accounting for the variables controlled by the strata. Way number 2 for sampling, cluster sampling. Sometimes stratifying isn't practical, and simple random sampling is difficult or impossible. In comes in a cluster. So here is honey bunches of oats, a cluster of things. Dividing the population into similar parts or clusters can make sampling more practical. Usually, the clusters are found in the population and are not created by the researcher. Then, We could select one or few clusters at random and perform a census within each of them. So this sampling design is called cluster sampling. If each cluster fairly represents the full population, cluster sampling will give us an unbiased sample. So in our context, a cluster could mean all of our students, freshmen through seniors, take a theology course. Everyone is equally likely to be in those theology classes. So if I randomly select 5 classrooms and ask everyone in that class to give me their answers, I will most likely be utilizing a cluster sampling technique. So in Divine Child, instead of class strata, we might cluster by selecting regions of the building. If we believe each region is individually a good representation of the entire population, think the hallway, room 111, the science wing, the gym, and then the art room, then using cluster sampling would be reasonable. So within each quadrant of the building, we could randomly choose classrooms and use every student, which is a census in that classroom, to answer our questions. Cluster sampling is not the same as stratified sampling. They sound similar, but they're not the same. We stratify to ensure that our sample represents different groups in the population and sample randomly within each stratum. Strata are internally homogeneous, meaning the same. Internally the same on some characteristic. Think freshmen, all the same, or sophomores, all the same. But the strata are different from each other on that characteristic. From freshman to sophomore, obviously grade level is different. Clusters are more or less alike, are internally heterogeneous, so they're mixed up, and each resembles the overall population. We select clusters to make sampling more practical or affordable. So again, it's this give and take between we would love to ask everyone, we can't. Sometimes simple random sampling is just unfeasible. Maybe strata could be practical. We can do that in some cases. Clustering, other times, is more practical or affordable. Usually, clusters are found naturally. So we think naturally occurring clusters. So your book uses this, and I think it's a great little analogy. So in stratified sampling, if you think of a rainbow cake, we would separate the cake into the individual layers and randomly choose from each layer for our sample. So if we peeled off each layer of the cake, then we can get a sample of each little bite. In a cluster sampling, we randomly select a slice or several slices of that same cake and eat the whole slice as our sample. So the whole 5 layers or however many in this rainbow cake would be our selection. With multi-stage sampling, sometimes we use a variety of sampling methods together. So for instance, we might choose 1, cut our cake into slices, and then 2, take those slices and stratify each layer. Sampling schemes that combine several methods are called multi-stage samples. Most surveys, conducted by professional polling organizations, use some combination of stratified and cluster sampling, as well as simple random sampling. So there's no one-size-fits-all or one method that we should use, although simple random sampling is the gold standard. So with systematic samples, okay, new thing, systematic samples. Sometimes we draw a sample by selecting data values systematically. For example, you might survey every 10th person on an alphabetical list of students. So we pull our roster of all seniors, and instead of assigning a random number, we're utilizing we're going to say we're going to go every 8th person on our list, boom, 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 boom. We're going to ask these people to answer our questions. To make it random, you must still start the systematic selection from a randomly selected data value. So instead of saying every time we do it the 10th time or 8th time, we'll use a random number generator to select what number we're going to start on, and we'll use a random number generator to figure out how many alternating numbers we'll go with. If there is no reason to believe that the order of the list could be associated with the variable studied, systematic sampling can result in a representative sample. So if you think that the thing that you're studying, the variables, do not relate to the way the list is ordered. Then systematic sampling could or can result in a representative sample, which is our ultimate goal. The primary advantages of a systematic sampling are cost and ease of selection. And again, if you want to do this and make it replicable, you want people to be able to actually re-engineer this idea. Okay, a couple more slides, and then we'll call this video. This goes back all the way to chapter 1 and 2, defining the who. The who of a survey can refer to different groups, and the resulting ambiguity can tell you a lot about the success of a study. To start, think about the population of interest. Who are we looking at? Often, you'll find that this is not a really well-defined group. Even if the population is clear, it may not be a practical group to study. So always think about who the population of interest is. Second, you must specify the sampling frame. Usually, the sampling frame is not the group you really want to know about, because we may not have access to some of the data values that should be included in our sampling. The sampling frame limits what your survey can find. Then there's your target sample. So who's the group you're actually using? These are the individuals from whom you intend to measure responses. You're not likely to get responses from all of them. Non-response is a problem in many surveys. And as we saw in that first video, if these political polling institutes are calling people on landlines and they're not answering, those non-responses are a pretty big deal. Finally, there's your sample, the actual data you managed to collect. These are the individuals about whom you do get data and can draw conclusions. Unfortunately, the sample may be biased. The data values might not be representative of the sampling frame or of the population values. So at each step, the group we can study may be constrained further. The who may keep changing, and each constraint can introduce bias. A careful study should address the question of how well each group matches the population of interest. Who do you care about? It sounds simple, but it ain't easy to accomplish. In other words, each time we limit the choices, the greater chance that our sample loses accuracy in representing the population. Every time we make a compromise in how we go about gathering the data, we may be introducing bias, or it could lose accuracy in being a representative sample. One of the main benefits of random sampling is that it never loses its sense of who is our who. The who in a simple random sample is the population of interest from which we've drawn a representative sample. That's not always true from the other kinds of samples. Think a stratified sample or a cluster sample. Since simple random sampling involves every member of the population having equal opportunity to be included in the sample, and every combination of members of the population is equally likely, we are more confident in the sample being representative of the population. And we want this to be representative. The more we try to make it easier on ourselves, the less likely it's going to be representative of the population of interest. Lastly, a valid survey provides desired information about a population. It is not sufficient to just grab a sample and then start asking questions. Before doing anything, a researcher must ask themselves, what do I want to know? Am I asking the right respondents? Am I asking the right questions? What would I do with the answers if I had them? And would they truly address the things I want to know? It sounds simple, but you'll be amazed by how difficult that can actually be. The questions may sound obvious, but there are a number of pitfalls to avoid. When you ask people questions, the wording definitely matters. So you need to know what you want to know. Know what you hope to learn and from whom you hope to learn it from. When you ask someone to go to the football game with you, what is it you really want to know? Going to the game or going with you? Two different choices, but They're embedded in the same question. Also, it's important you use the right frame. Be sure you have a suitable sampling frame. Asking patients which surgery is most appropriate is probably not the best sampling frame. So, one more point about asking survey questions. Make your questions specific rather than general. So, to design a valid instrument, the instrument itself can be the source of errors. Too long of questions yields fewer responses, or too long a survey yields for fewer responses. Ambiguous questions yield meaningless responses. Hi, how you doing today? Good, thanks for asking. How are you? Doesn't actually get me to see like, what did you do today? Or how are you feeling in this moment? Ask for quantitative results when possible. Be careful in phrasing questions. A respondent may not understand the question or may understand the question differently than the way the researcher intended. I think we've all experienced times where you ask someone a question and they don't actually hear the words that you're asking them. They hear something different. You always have to be mindful of how you phrase a question. Even subtle differences in phrasing can make a huge difference. And it's usually a better idea to offer choices rather than inviting a free response. So the best way to protect a survey from unanticipated measurement errors is to perform a pilot study. A pilot is a trial run of a survey you eventually plan to give to a larger group. So always run a test first and see where the kinks are. It's like with anything, you want to present it to a couple people, be like, hey, I'm looking for some feedback. Can you look over these questions? Could you see if there's any holes that you want to poke through this? So we're going to pause here because the last bit of the notes is going to talk about how can you do this poorly? And there is a lot of ways you can go about sampling poorly. Again, this whole goal is to go about collecting data and then be able to make conclusions and inferences from it. So it's really important that when we go about collecting data, that we do it in these appropriate ways. So I look forward to seeing you in part 3. Part 3 should be short. I'll see you in the next one, Falcons.